Is tangent positive or negative in the first quadrant? Is tangent positive or negative in the first quadrant? Positive. Positive or negative second quadrant? Negative. Positive or negative in the third? Positive. Positive or negative in the fourth? Negative. So notice it goes positive, negative, positive, negative, positive, negative, positive, negative. So it just rotates between positive and negative, correct? So how long does it take to actually repeat itself? Sine went positive, positive, negative, negative. So it took a whole 360 to repeat itself. Well, if tangent goes positive, negative, it just takes 180. So instead of taking 2 pi and divide it by b for tangent, we take just pi and divide it by b. So if you have an equation in the form y equals a times tangent bx minus c, we could add, a d onto that and do the same stuff we've done before, but I'm not going to test you guys on that. That will be included for sine and cosine, secant, cosecant, all that good stuff. But as far as this is concerned, we're just really going to play with the period as well as the a value. A does not refer to amplitude in terms of tangent. Horizontal shift, ax minus c equals 0. Solve. Just like normal. And then you would shift everything. And we're not going to do any examples today with shifts either. You might see it on your worksheet or in your study guide, but not a big deal. We'll practice the other stuff today. Okay, you need your calculators out. Take out your calculator or watch mine. So the question is, what does tangent look like? And if we start to generate some values, there's kind of some interesting pieces there. So let's start with the first quadrant. And because you're more familiar right now with degrees, as most people are, than radians, let's choose to work in degrees right now. So I'm going to go down to degrees, enter. I'm going to go into y equals, and I'm going to plug in just tangent of x. Okay? And instead of going to the graph, I'm going to go to the table. And if I go to the table, I'm going to punch in some numbers and generate some values. Okay? As you can see right now, I've got 0, 1, 2, 3, 4, 5, 6. Is that because my table set is, yep, it's on auto. Set to ask. Okay, here we go. All right, so the tangent of 0 is 0. Okay? The tangent of 10 degrees, 0.17. Smaller than 1. Tangent 20 degrees, still smaller than 1. 30 degrees, still smaller than 1. 40 degrees, still smaller than 1. 45 does happen to be 1. Okay, let's see what happens as we get close to 90. So we finally reached 1. How big do you think it goes? 50. We get a bigger value than 1. Do you think it goes all the way up to 2? 10? Hard to know, isn't it? Watch. We got 50. We got 60. Not quite 2 yet. 70. Oh, now it's 2.7. 80. Now it's 5.6. What if we try like 89? 57. What if you try 89.9? Or 89.99? 89.999. What's happening to the values? They're getting extremely large. Extremely large. If you plug in 90, you get a value that is undefined. Let me teach you why that is, why we're generating that stuff, okay? If you remember, in terms of x, y, and r, tangent of theta is equal to, does anybody remember? Y over x, very good. And y over x is simply rise over run, which is slope. Well, think about it. If you draw an angle that is, that has a lot of slope, right? What's the slope of a vertical line? Vertical line is undefined. So you cannot take the tangent of 90 degrees because you would get a vertical line that's undefined. Whereas if I just back off a little bit, do like 89.99999, you're going to have a very steep slope, right? In fact, that slope is going to approach positive infinity. So it's going to get really, really, really big. So when we're talking about tangent, we're talking about slopes. So you can have zero slope, you can have undefined slope, you can have positive slope, you can have negative slope, you can have all that stuff. So tangent is going to oscillate between those values, okay? So let us consider that. Flip your notes over to, yes, this part right here. Asymptotes occur for undefined values. So tangent is undefined wherever the angle is straight up and down. Okay? Where is it straight up and down? 90, or so tangent is undefined for, say, pi over 2. Or 270, which is 3 pi over 2. Or back up to that 90 spot again when you come around, which would be 5 pi over 2. And it just continues on and on and on and on. You could have the negative values as well. Now, tangent is going to be equal to 0 wherever you have a line that has a slope of 0. What angles give you a slope of 0? A flat line right across the x-axis. 0, pi, 2 pi, values like that. And they continue to go on and on. You could actually express it like this: pi times k, where k is any integer, would generate, a value of 0. So you could express it like that. That's the way a lot of books do it. Okay. So we have tangent is equal to 0, pi, and 2 pi, or equal to 0 at those spots, and it's undefined at those spots. Tangent repeats itself every, how often? 180, which is pi. So tangent repeats itself at these same spots. So this is the most important part of the day. What I write here, 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 and here. Tangent is equal to 0 at the period. So when we mark out the period on our graph, we know that that's where it goes through the x-axis. Tangent is undefined halfway in between. It's equal to 0 at the periods. It's undefined halfway in between. So I put a dot where it crosses the x-axis on the periods. I put vertical asymptotes halfway in between. So let's go back to the previous page and let's graph what this looks like. It says y equals tangent of x. Now I'm going to put down 2 periods on each side. So tangent of x, period, is equal to pi divided by your b value, which is 1. So pi. So I'm going to mark pi and 2 pi, negative pi, negative 2 pi. Thank you, Kelly. Now, vertical asymptotes are halfway in between, but at the period, the graph is equal to 0. So I'm going to put dots on the period because this graph is going to cross the x-axis through the period spots. Does that make sense? We've investigated why. Again, that's where you have a flat line. The slope is 0. It's undefined halfway in between. So what do I need to draw? Vertical asymptotes. Now, do you remember, if you took the tangent of 0, okay, let's look at this. So this is 0, and this is pi over 2, right? Is tangent positive or negative between 0 and pi over 2? It's positive in the first quadrant. So you're going to have positive values come out of it. Let's look at my next area. Pi over 2 to pi. That's which quadrant? Pi over 2 to pi is which quadrant? Second quadrant. Is tangent positive or negative there? It's negative, so I'm going to have negative values. Pi to 3 pi over 2. That's the third quadrant. Values are positive. So it's going to continue on. And fourth quadrant, it's negative. So you can continue these type of shapes all the way through there. And that's why it achieves those values that it does. You can see the values go on to positive infinity, negative infinity. Those represent all the possible slopes that you would have of lines. Because again, tangent represents slope. Well, not intentionally. I guess it just happens to be a relationship. But we like to talk about it. What do you think? What? Phone goes. Pause. Okay, so your question, Billy Barber, was what? What was your question? Okay. All right. So let's try an example here, okay? So we do tangent of pi x. If I want to evaluate the period, I take pi and divide it by b. What do you get if you take pi and divide it by b? 1. So the period's 1. I'm going to mark out 2 sets of the period on both sides. 1, 2, -1, -2. Any questions how I got that? Why don't we divide into 4? Because sine and cosine repeat themselves in 4 quadrants. Tangent and cotangent repeat themselves in 2 quadrants. No, that's not a very good response to you either. Let me think about your question a little bit more. How about this? I am choosing to do this. A lot of people might say, you know what, I don't want to write 2 full sets of the period. I'm just going to write 1 set of the period. So some people might just put a 1 there and a -1 over there. That's fine as well. That'll be an okay representation. I'm going to get to your question, though. I can answer it here in just a second. Watch. Okay. Does everybody know how I got these markings, though? Now I move on, and is tangent equal to 0 at these spots, or is it undefined at those spots? 0, so I put dots there. Now, my good friend Casey asked about dividing it up. I haven't done any dividing yet. I'm going to divide it now. So we used to divide sine up into 4 pieces for the 4 quadrants. But now we're just going to divide each period up into 2 pieces for 2 quadrants. Okay? So let's do that right now. It's undefined in between. So notice this period right here from 0 to 1. I take that and divide it into 2 pieces because it's just it repeats itself twice within 360. Does tangent start down and finish up, or start up and finish down? Starts down, finishes up. Any questions how I got that? So there's really 3 steps you got to think about. A, generate the period. Second of all, mark your zeros and your asymptotes. Third, know the direction. Does it start down, finish up, or start up, finish down? And that's it. Let's try another one. What's the period for problem B? pi. Pi divided by b will generate a pi value for me. I'm going to show two sets of the period. So again, I'm not dividing this up yet. I'm just representing it many more times than I did my sine and cosine graph. Sine and cosine, we just generally showed one full period. We divided that period up into 4 sections. Whereas for this one, I'll divide it into 2 because, again, within a period, there's 2 quadrants. All right, so is it equal to 0 at these spots, or is it undefined? It's equal to 0, so I put dots on the periods. It's undefined in between. So I draw vertical lines, asymptotes. Do you draw good lines? Okay, whatever. Does it start down and finish up, or start up, finish down? Why does it start up and finish down? Because it's negative. That will reflect it. So I start up and I finish down. Oh, good question. I was waiting for that. The 2 is a vertical stretch. With sine and cosine, I represent the amplitude. You don't have an amplitude here. But here's what I can tell you. I haven't represented the 2 at all in this case. But if you were to draw the slope of this curve right at 0, it would match with whatever number was in front. So in this case, there's a 1 in front of the tangent. The slope at that spot would be exactly 1. Whereas in this case, the slope would be exactly, -2. Now, how do you know that? You got to know calculus to know that. But that's what it ends up being. Okay, so if you want to know, that's kind of how it shapes it. Okay, stretches it. Okay, so can you graph tangent? Let's do cotangent. Now this is where the understanding really comes together, and it's really cool. It's almost identical, but you just got to make a relationship, okay? A connection. So you tell me, what is the relationship between tangent and cotangent? Opposites like 2 and -2. They're not opposites, they are reciprocals. They're the one flipped over, right? It's like 2 and 1/2, okay? So think about this. We're wondering where tangent is equal to 0. What's the reciprocal of 0? Undefined. So this stuff goes to where cotangent is undefined. What's the reciprocal of undefined? 0. So this stuff goes up there. So where is cotangent equal to 0? Well, it's equal to 0 for values of x equals pi over 2, for 3 pi over 2, 5 pi over 2, all values like that. And cotangent is undefined for values like 0, 2, or pi, 2 pi, 3 pi, so on and so forth. And so cotangent is equal to 0. Do these represent the periods, or are these halfway in between? Nope. Halfway in between. Remember, cotangent repeats itself every pi. So these represent the periods. So cotangent is undefined at the periods. So that's what happens. They switch. All right. So let's give it a shot. Oh, we're not ready for that. That's tomorrow. Okay, cotangent of x. Basic parent function graph. What's the period of cotangent? Pi over 1, which is pi. So I'm going to mark it out. Pi, 2 pi, negative pi, negative 2 pi. At those spots, should I draw dots or should I draw lines? Lines, because it's undefined at those spots. Very good. You got really nice lines. At least one person giggled. Remember to draw one on 0. Remember, it's undefined at that 0 spot. I always got to make sure you include that 0 spot. Because, remember, it all switches. What used to be for tangent is now true for cotangent. Here they switch. Okay, and it's equal to 0 halfway in between. So halfway in between these, I draw my 0 dots. So I've got my 0 dots. Now, this is the last piece you have to connect with, and then you'll be golden. Okay? Look at tangent. Just to the right of 0. Just to the right of 0. Is tangent a really large value or a really small value? Just to the right. Really small. What's the reciprocal of a really small value? A really big value. So if you go just to the right of 0, you're not going to have a really small value. You're going to have a really big value. So it starts up here and it finishes down here. So cotangent is also flipped upside down from what tangent was. All right, let's crank out a couple problems. What is the period for letter C? Period's going to be pi divided by 1/4. What's pi divided by 1/4? 4 pi. That's your period. So I'm going to mark 2 sets of that. 4 pi, 8 pi, -4 pi, -8 pi. Some people said all these graphs look the same. They do, but if we were to graph them on the same set of axes, they would look very different. You know, this one's stretched out a lot, right? Okay. On my periods, do I put 0 dots or do I put lines? Lines, because it's cotangent. I was going to ask you if I had nice lines, but I thought that might be awkward. A little bit more of a laugh that time. Not much. I'm not very funny today, Kelly. Only funny looking. All right. Now, it's equal to 0 halfway in between. So now I plot my zeros. Is it going to start up and finish down or start down and finish up? Start up, finish down. Yeah, it looks like you're so smart. Looks could be deceiving. I like it. Okay, the last one. What's your period? Close, not quite. Pi divided by pi over 3. The pi's will cancel and leave you with 3. So I mark off 3. I mark off 6. -3. -6. Do I put lines through the period or zeros on the period? Lines, because it's cotangent. Lines. Lines. And it's equal to 0 halfway in between. Does this one start at the top and finish at the bottom, or start at the bottom and finish at the top? Why? The negative flips it from its normal position. And Bailey Barber said that she was really smart. And I agree. I think you're way smart. I'm going to even type this in to show you how smart you are. You can't graph cotangent on your calculator, really. You have to do divided by tangent. And then if you put in, say, second pi divided by 3 times x, and we work in radians, and I make my window into negatives. You work in radians really all. I just went to degrees because that would be more familiar for you guys if you're checking something. But you should really always work in radians. And then I've got 3 is every tick mark. So if I press graph again, you can see I can check that. And you know, Bailey's right. We do look really smart when we can put out the same thing as our calculator did in about the same amount of time. What do you want? How do you change what? Mode. You're welcome. Here's your assignment. And these problems, they actually go pretty quick. You just got 8 of them. Remember, there's your assignment for Thursday. I've got study guide, and should I just give you guys your study guide and homework sheet now? I'll just give it to you right now. Okay. And then I'll come around and help you.